Okay, I gotta go. Bigger text. Much bigger text. Big text. Alright. Alright.
85 by 30 is good enough.
Alright, good.
I wanted to turn my house.
Alright, good. Alright. Onward, Christian soldiers. Or something.
Alright, so.
Onward, Linux legions.
Whatever.
So
Little swamp.
Today's talk, in 2 parts, is, well, hopefully the part of this will work. If not, I'll have to walk you through it blindly. It's a service that necessarily won't work. I'm going to show you how to configure the Nginx web server for serving static files over SSL so that you can have an SSL encrypted something.
So this is based on Nginx?
Yeah, it's going to be based on Nginx. You can do the same thing with Apache if you with some directives, and I could probably patch that in, but I'm not going to worry terribly much about it because once the big thing is getting an SSL certificate that's not self-signed. For that, you can do a service called StartSSL, and we'll see if this actually works. Because earlier they were over capacity. So if you go to StartSSL, first off, they use an authentication thing that no one else really does that everyone else should do. They use a client SSL certificate. So when you first sign up, they'll ask you to create a client SSL certificate, which is based on your email address is the common name. And it's stored in your browser. So then when my browser goes here, my browser connects, it's going to do this and choose which certificate to present as identification. So I present the one I created earlier. I can't show you the creation process because it'll screw things up. I could probably get Sam up here to create an account with StartSSL maybe. But it's not terribly important. It just walks you right through. I didn't have to do anything. It's just part of the login process. So I send the SSL certificate, and I get signed in. There's no passwords involved. This SSL cert, I have to export from my browser if I want to do this from a different computer. But so here's StartSSL. I've actually paid them some money, so I get advanced features. But if you just don't pay them anything, you get to do
$199.
to get these validations. Well, that's for the really advanced stuff. You don't need that. To do a domain name validation, you go through this and you select your domain name. It's got to be something or other.com or .net or whatever. It has a fairly complete list.
I'd say so.
I don't think it has all of the new ones, but they're.
Amazon.
Yeah, you can't register .amazon. Yeah, only Amazon can register .amazon. But anyway, so you type in whatever in here. I'm actually going to do one that I don't think I've done before. Man, I remember when US used to be like the only one with you, practically. All right, so I'm going to try to register this one. Yes, I actually own this domain, d.myland.us. It's currently a Tumblr blog, which is sort of, I won't be able to use an SSL cert, but it's for purposes of. Ah, yes, that's right. So unless you're doing the advanced registration, you have to do the base domain. Actually, you always have to do the base domain. So this will just be myland.us. And then if I wanted to continue this process, it's how you verify. Yeah, so you have a domain name. Say your domain name was wyland.us, and you want to register StartSSL for it. You would have to go through this validation process, type in your name, type in your domain name, and then it would send it to either the postmaster record. Whoops, can't resubmit the form. Type in domain name, whatever the postmaster, if there is a postmaster, start of authority. If there's a start of authority email address associated with your domain name, it'll select that. Otherwise, it'll want to email postmaster at whatever the domain is. You respond to the email, which proves that you control the domain, and then you are registered to use that domain. It doesn't cost anything. The reason it doesn't cost anything is it's very automated on their end. They don't have to like dedicate a person to it, and they'll let you have a single domain. If you pay them $50, scan a bunch of personal identifying information. I don't know how you feel comfortable about this, but it's sort of a trust thing. But you scan like your passport, driver's license, and some other stuff, and submit the photos to them. A person will check it. The person will call you back on the phone, verify your identity via the phone number, and then you can register a wildcard.domain. So notice the HTTPS. This is a completely blank web page, but it is a valid SSL certificate that I've registered using the latter method. That, like I said, it does. To get a wildcard, why do you do this in Chrome? I need to start using Fire. Oh, there we go. If you look under connection, certificate information, start.hardison.net, organization, Dylan Hardison, there's no organization unit, issued by, StartCom, class 2. If you do the free one, it'll say class, it'll say StartCom 1, and it will have less information about who registered it. Like, I think it might just include the email address. But nevertheless, if you've gone through this, you will now have 2 files. You'll have a key and a certificate. Possibly a certificate chain, which don't worry about it. I think that they're all bundled together in the cert that it gives you. So you take the cert and the key, and you have to configure the thing that you want to use SSL. I use Nginx because it's faster than Apache and uses significantly less memory and is very configurable.
Leap large buildings in a single bound.
It can leap large buildings in a single bound. My config files. So to do that, I've actually kind of golfed my config file so that it's very small, but I'm going to ungolf it for this usage. And we're actually going to create a separate, you could create a separate instance of this. So ignore that. Inside your Nginx file, everything that you need to do to configure HTTP stuff is in the HTTP block, and everything that you need to do, you need to also edit the file through. So, I want to have what domain, what things I currently have pointing at there. I don't have any. I have to use one that's already pointing. So, we are going to just rewrite this section by hand. Well, we're going to cheat.
Oh, that's off the screen.
It is. That's convenient.
Oh.
You won't be able to see. You won't need it. Really? Oh. They need to be fully root. That's annoying. Whoops. Alright. Now we're cooking with gas. So first, before I actually start doing that,
Cool.
that wasn't supposed to happen. That was weird. Alright, so I've suspended the editing session. The files that you'll get, and I think that I feel confident showing this on the screen. If, well, NSA probably already has it anyway. So I'll briefly show the public cert. So this is the part that's not private. This is the public key. Begin certificate. Looks like this. It's actually 2 certificates. No, there's actually 1 certificate in here, and it's the one that they gave me. It's the part they generate. The key.
That's really nice.
Just so you're aware of this, the key. Actually, there's the other cert. I think it's probably a different cert. This is the one they actually gave me, which you can't see.
That's a really good one.
It's really good. No, certificate, big cert, long certificate. It's the public portion. This is what the web server presents to the browser to verify the connection. The private key, and I want to point this out for those that are security-minded about things. StartSSL is pretty secure in some ways. The private key file you get to generate yourself. If I actually go through the whole process, there's a place where you can let them generate it for you, or they give you the command that you run on the command line to generate a private key, and then you just upload it, and they sign it or they strip off the information that you've added to it, so you don't get the common name that you put in there. So you can only get the common name that they want to give you. The common name being like the domain name. So if you aren't paying for the wild card, you can't get the wild card. But the private key portion is still part you generated, and they sign it and you get it back. So they technically could have a copy of your private key. Could they maintain a copy? Well, let's do it. So we will actually go through that annoying process. That's where I log out.
Oh.
The user interface on this thing is so annoying. I always have to look around to figure out how. Oh, domain validation.
Almost reminds me of a website out of the 80s.
Well, you'll get what you're paying for, you know?
No, what's that? The 80s print frames.
I think this says iframes. That makes it modern, right?
Sure.
Earlier, when I was like trying to prepare for this, it said that there were overcapacity. So hopefully I'm not staring you. You know what? It doesn't matter. We don't need that.
Okay, so those are not frames. Those are something else.
Those are iframes. I think.
iframes.
I don't actually know.
Okay. Well, as long as you don't actually know. Yeah.
Nope, there are no iframes in it.
Good. So what are those little thingies?
Oh yeah, I could use this as an open ID endpoint as well. I was going to show you the workflow of doing the certificate, but it's acting so slow now that it would be pointless. Or if not pointless, very annoying. So very briefly, private key, you saw part of it. That private key I generated myself and uploaded to them. So I don't have to necessarily trust them a lot. So I don't know if you're truly paranoid, this isn't going to mean much, but what we're talking about here is having an SSL certificate that other people will trust, so that when you visit it in the web browser, it doesn't say self-signed certificate. Does anyone have an example of a public-facing website I can point to that has a self-signed certificate, so I can show people what the error I'm talking about is?
Go to arspionline.org.
With SSL?
Yeah.
Woo! So this is the warning you're trying to avoid getting, because it's scary. Isn't this scary? And it doesn't necessarily mean anything bad. It just means that the person that signed the certificate, or the entity that signed the certificate, is signed by itself. It isn't signed by one of the certificate chains that's in your browser by default.
The site's full of bugs.
So you can help me understand, and probably explains it better. But anyway, so you can go back to safety. Let's not do that. Whereas this one, which is sorry for your noise. Whereas this is my website, which is empty. So it's empty, and there's no content there. But if I look at, like I showed you earlier, if I click on the certificate information, for one, it says identity verified. For two, the HTTPS is green, and HTTPS being green is very good. It's not great.
Here's a green light next to it.
Yep. Using 256-bit encryption, TLS 1.2, ES256, SHA-1. Ooh, this part's bad though. Really, you shouldn't be using SHA-1 anymore, so I might have to reissue my SSL certs.
Okay. What's the matter with SHA-1?
It's just getting weaker. What?
Computers are getting faster and faster, and shorter certificate keys are living secret every time.
Okay.
So, where was I going? Yes, config file.
What is TLS1?
TLS is the current version of SSL. Transport layer security versus secure socket layer. I mean, it's like a little later. I don't know why the lettering changed. it says somewhere in the Wikipedia article, it's not very interesting. But TLS is basically SSL. Like TLS 1.0 is the same as SSL 3.0 or something like that.
It's there to confuse the common man.
Yeah. Anyway, so you get what I was trying to point out is you get two files. So here's our two files: the key, which I've named I've named these the way they gave them to me. I forget what naming convention, but it was kind of horrible. So I named it with the domain name. Where the dots replaced with underscores, and there's a cert and a key. The cert is the public part if you know about encryption. If you don't really care, you have two files. So what do you do with these two files? You need to have a directive for Nginx to tell it which files to use. And there's three directives that Nginx needs to have. For one, you turn on SSL. Two, you specify a certificate key, which is this word here. And then, certificate, and then you specify a certificate key, which is this third and final line. I put that into a separate file because as I said, I golfed, which means I cut down on the size of my config file. So I include SSL. I'm including SSL in anything that I'm using SSL for. So I have this is like the main HTTPS server that's listening, which handles lofen.hardison.net, which is nothing useful. Lofen happens to be the name of the computer this is on. I also run a continuous integration server named Jenkins, and I have this one here. So this is the non-SSL connection. You see the same port 80, and it's not including that, and I just redirect it to SSL. And then here I just include SSL again. So it's as if I had those three lines repeated. You can do this in Apache too, right? You can include files. And it's roughly the same thing, and I think the keywords are different, but it's not terribly different. So that's literally all you have to do is trust StartSSL.com for one. Yes?
On those different sections where it says listen, lofen, hardison.
Yeah, I should explain that actually.
Did you put a loopback address there?
Yes.
Okay.
Well, when it says listen and there's a lofen.hardison.net, that's just me being lazy. That resolves to an IP address, and I mean only listen on that one IP address for the server. The reason I do this is I have some other stuff going on the server. It has multiple IP addresses. That's ignoring the weird ones. The weird ones with colons are either a MAC address or an IPv6 address. Ignore those. So let me get it. I want it at the top of the screen or near the top of the screen so I can point out. I have this is one IP address .40 or 69.56.173.41. I also have this other IP address. This first one is symbolic name or its domain name is lofen.hardison.net. That's the one everything runs on. The other IP address is for running other stuff to get around firewalls on. So the reason my Nginx config file says listen and has a name and then a colon is so that it's listening specifically on the first IP address. Now I could just write the IP address in there, but I'm lazy and I don't want to have to, if my IP ever changes or I move to a different hosting provider, I don't want to have to. I don't want to have that hard coded in the file. It also means if DNS is down, that this would break. If DNS was down and I restarted the web server, and it couldn't resolve lofen.hardison, then it would fail. It wouldn't be listening on this socket. I think it would error out. The server name portion is for name-based virtual hosting, and that's a thing. If you're doing SSL, there's this weird thing to read on the internet about doing SSL and name-based virtual hosting. What people will tell you is that it doesn't work, which is kind of true. If I wanted to host foo.com and bar.com, I would need if I wanted to make that work, and I had one SSL, I'd have two SSL certificates, right? So one for each. I would need two IP addresses because when the browser connects over SSL, it doesn't know, it has no way of telling the web server which thing it's expecting. So the web server has to know what certificate to use, and there's no way for it to know, so it can only send the one. But if you have a wildcard domain, if you were able to, if you have something.foo.com, like alpha.foo.com and beta.foo.com, and you can get an SSL certificate for star.foo.com, then any foo.com domain name can be hosted. You can have them redirect to different resources and do name-based virtual hosting just fine, as long as you're using the same domain name. Or if you can register a SSL certificate for star.com. But if you find someone that will give you a certificate for star.com with, like, if you could find that, that would be amazing, because you could break a lot of stuff. So no domain, no SSL issuing authority is going to give you a star.com. I mean, unless you're the NSA, I'm sure they give them out like candy if you are. So,
What file are we looking at right now again?
this is nginx.conf. It's the main file for nginx.
And
I've simplified it a lot.
yeah, but all right. The question is about the listen. Now you have it loafin.hardison.net substituted as your WAN IP address.
Yep.
How does it differentiate? Is it just known because of the program that it's going to be a WAN IP address, or why doesn't that also resolve to your loopback address?
Well, your host name should never resolve. The host name of a machine should always resolve to its most public IP. You shouldn't like have it be on the local host line.
That would be controlled by your, it's supposed to look at the hosts. If you look in your etn-swish.com file, it'll list the order of how it's supposed to look at the host. Most will have files followed by DNS, followed by whatever alternative solution you have. All that, and I answer.
So in answer to your question, yeah, so if this didn't resolve to the right thing, then I would be binding it to the loopback, and that would be that. But usually, in a situation where this is behind the NAT, then I think that I would just have it, I wouldn't bother, I would just tell it to listen on every address, or on any interface with this, by saying listen 80. The reason I'm doing this is I have 2 public IP addresses, and I want it to listen on a specific one. So the second part, this is server name. I forget how you do this in Apache as well, but there's another way. It's name-based virtual hosting. So the server name here, when the browser connects and the SSL connection is already established, it sends as one of the headers, it sends the host name that it thinks it's connecting to, and then that will redirect it to whichever one of these server stanzas most closely matches it, or matches it exactly, not most closely. There's a couple of things going on. The ci.hardison.net is actually just proxying to something else, as you can see here, which is kind of standard.